Okay, so I want us to imagine the following example. Let's imagine that the client is some game engine. So let's imagine that we have some game engine, and the game engine goes ahead and works with a rectangle to draw it on the screen. But the problem is that the legacy rectangle that we currently have returning from some framework that we're using, some library that we found, the rectangle over there is not compatible with what we in the game engine expect. So we have over here the, let's call it legacy rectangle. And the legacy rectangle has methods like calculate area, calculate perimeter, and finally, let's say shift. But like we said, this is not what the game engine needs. The game engine actually needs things like get area, get perimeter, and let's say move. And as you can see, I'm changing all the types over here to be long and not int. This is what the game engine knows how to interact with. The game engine wants to interact with the legacy rectangle, but it can't using its current interface. So what we do is we create another interface. Let's call this the I rectangle, and we'll have over here the legacy rectangle adapter implementing all these various methods. So this is a simple example that I'm sure you can imagine various equivalents for this in your code base as well, where you just have some legacy object that you need to work with, or some interface in general that is just incompatible to what you need. So instead, what you can do is create your own interface, interact with that interface, and simply have some adapter that goes ahead and does the conversion. Now, this is a good place to mention that this design pattern is also referred to as a wrapper, where we have some object which is the incompatible type, and we're wrapping it with a new interface, which the client can now interact with. Okay, now let's go ahead and do a quick section recap, and then let's go ahead and implement this in code. So in this section, we got familiar with the adapter design pattern. Like we said, this pattern is actually pretty simple. It allows us to convert the interface of one class to another class. This way, we can have objects that wouldn't have been able to interact with one another, interact with one another. We then looked at the class diagram, which overall has three components. We have the target, which is what the client will be interacting with in compile time. We have the adapter, which the client will be interacting with in runtime. And we have the adaptee, which is the incompatible interface. To further illustrate this, then we gave an example of a game engine where we have some legacy rectangle that the client wants to go ahead and use. But it can't use it because the client expects a specific interface. In our case, it's the get area, get perimeter, and move. All the underlying primitive types are long and not int, and it can go ahead and use the legacy rectangle, which has a different interface. To fix this, then we will use some interface which goes ahead and is the interface that the client expects. We'll then have the adapter implement this interface and adapt between the old interface and the new interface. Now let's go ahead and implement this in code. Let's go ahead and implement the adapter design pattern. I want you to first notice that over here we have various folders, and each folder corresponds to a subfolder. Like in any course in Dome Train, in the beginning and end of each section, you'll have a zip file with the code as it was at that point. Meaning that if you download the zip file that you have in this subsection, because this is the first subsection, then you'll have over here the two class diagrams that we built in the previous section. Plus, you'll have this empty project, which you can now open and follow along with me if you'd like. Okay, so overall, like we said, we have the three main components. We have the target, we have the adapter, and we have the adaptee. So let's start with the adaptee, which is again the one with the incompatible interface. Let's say that we have over here the adaptee, and inside here we have the specific request method, which let's say simply prints to the screen adaptee's specific request invoked. Then we have over here the client, and the client wants to go ahead and call the request method because that's what it knows to work with. So we have the client wanting to call the request method on an instance of the adaptee. But it can't because it only has the specific request. So like we said, we go ahead and recreate some interface for the client to work with. Let's go ahead and call the interface the iTarget, and the iTarget will have the method needed by the client, which is the request. So let's say over here that we have the request method, and the client goes ahead and interacts with this interface. So let's say we have over here the target, and now the client can go ahead and say target.request. Of course, we're also missing the actual adapter that implements this interface. So let's go ahead and create below the iTarget, let's create the adapter, and this implements the iTarget. This adapter will simply have in it the adaptee, and when this method is invoked, and then we'll go ahead and say adaptee.specificRequest. Of course, we're missing over here to say that this is a new adapter, and the adapter needs in it a new adaptee. Now, of course, to get your hand on a concrete iTarget, you don't necessarily have to go ahead and explicitly create it. This can be populated via dependency injection or some configuration, etc., etc. This is just to simplify the example, and the beauty is that the client in the end interacts against the iTarget interface that it knows how to interact with, and the adapter or what sits behind this interface can change in runtime. Okay, now just to make things a bit clearer, let's go ahead and move all of these to their own classes. So overall, what we have is we have the client code needing some specific interface, and to interact with this interface, then it's working against the adapter, which goes ahead and does the conversion between the interface that the client knows how to work with and the interface that exists in the adaptee. Now let's go ahead and implement the game engine example. Okay, let's go ahead and implement the game engine example. Now what I did is I simply copy pasted the previous example, the base example, and I copy pasted it to 3.2. Now what I want to do is to just start by replacing the underlying components. So the adaptee is no longer the adaptee, but this is the legacy rectangle. Like we showed in our example, then the legacy rectangle will go ahead and have these methods. So let's go ahead and give this the calculate area method. Now, of course, the legacy rectangle also needs the underlying data. So let's say that we have over here the left, the top, the right, and the bottom, and using these values, then you compute the underlying rectangle. Now, to calculate the area, all we need to do is to multiply the height and the width. So let's say over here, return, and let's say bottom minus top, and let's multiply this by right minus left. This will give us the height, and this will give us the width. Next, we have the calculate perimeter, where the calculate perimeter is simply 2 times the height and 2 times the width. So we can go ahead and say that we have the height equals this thing. We then have the width being this thing, and the perimeter is simply 2 times the height plus the width. Okay, so 2 of these are 2 of these, and we still have the shift. The shift is basically taking the rectangle and shifting it by some offset. So let's go ahead and duplicate this method and implement the shift method. The shift method, like we said, receives a horizontal and a vertical, doesn't return anything, and simply updates the underlying points to be shifted by this offset. What we want to do is we want to take the top and the bottom and add to both the top point and the bottom point the vertical offset. Plus, we want to go ahead and take the right and the left and add to them the horizontal offset, moving both the right and the left based on the offset. Next, what we want to do is to implement the interface that the client wants to interact with. So like we said, we have the I rectangle that the client wants to interact with, and this has similar but different methods. This has the get area, the get perimeter, and the move method instead of shift that receives a long dx and dy and doesn't return anything. Let's update the name of this file to be iRectangle, and once we have this, let's go and implement the adapter. The adapter, we said, will be called the legacy rectangle adapter. So let's call this the legacy rectangle adapter. And our adapter will implement the I rectangle and will hold inside it the legacy rectangle. Let's, of course, implement the interface, which will simply be over here returning the calculate area. In the get perimeter, then it'll be calculate perimeter. And in the move method, then it'll simply be calling the method shift and passing it the offsets. Of course, we also need to go ahead and now convert the longs to int. And to do this, all we're going to do is say convert to int 32 and pass it the dx, and same thing for the dy. Now, of course, the conversion from long to int won't necessarily always work. And over here, we may be throwing an exception. So when we call 2 and 32, then this may throw an overflow exception if the value is greater than int. And this is, of course, something that you want to take into account. Okay, now that we have all of this, then back in the client, we can go ahead and represent the game engine. Now, let's imagine that in the game engine, then we have some method that needs to process the rectangle. Let's say we want to center the rectangle. So we have some method called center rectangle, and this receives the I rectangle because we can't work with the legacy rectangle. And this method knows how to go ahead and move the rectangle to the center. Now, the client can go ahead and call center rectangle and pass it a new legacy rectangle because these types aren't compatible. Instead, what we'll do is we'll go ahead and define the I rectangle to be a new legacy rectangle adapter, and we'll pass this to the center rectangle method. Now, to implement this, then we want to pass over here the new legacy rectangle, which is the object that we already have in our hand that is incompatible. So theoretically in runtime, most of the time, you'll already have the concrete object that is incompatible in your hand, and you'll simply pass it to the adapter. So for the values, let's just give this something random like the following. And actually, let's also move this to its own variable, just so this represents the fact that we already have this in our hand. So I say legacy rectangle equals this, and we pass the legacy rectangle to the adapter. So overall, what we have is we have the client being able to use the adaptee using the adapter, where the adapter goes ahead and implements the target. Now let's go ahead and do a quick section recap, and then let's go ahead and talk about the benefits and the drawbacks of using this pattern. So in this section, we implemented the adapter design pattern twice. In the first time, then we simply used the terminology of the design pattern, which is the iTarget, the adapter, and the adaptee. And we saw that it's pretty simple. Basically, what we're doing is we're creating an instance of the adaptee, or we're taking the instance that we have, and we're using the adapter to give the client some interface that it can work with. We then went ahead and we implemented our specific example with the game engine and the legacy rectangle. We imagine that we have some method in the client called center rectangle that knows how to center a rectangle, but we have the legacy rectangle which the client can't work with. What we did is we created the legacy rectangle adapter that knows how to go ahead and adapt the legacy rectangle to the modern rectangle. And of course, the adapter needs to implement the iRectangle interface. So hopefully this was very straightforward after talking about the theory in the previous section. Now let's go ahead and talk about the benefits of using the adapter design pattern.